Hey guys, it's Ms. Brady, and I just wanted to make sure that I took you on a review of our solar system. I assume that you know about the solar system in general, and I just want to point out a few things and show you some things you might not know. So, you know that Pluto has been demoted to a dwarf planet. Just to review the order: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and Pluto. This is how we move through the universe. We always show the solar system as being on a flat plane with the sun, but remember that the sun is revolving around the galaxy. So we're actually shooting through space in this odd helix sort of shape. So when you think about the fact that we have left our Earth and go to the moon and returned, it's pretty incredible. And I want you to imagine how people talk about, like, oh yeah, we'll just hop on over to Mars, visit Jupiter. It's incredible how you have to calculate and project in order to be able to make it to a completely different celestial body in the solar system. So yeah, that's how we move. Just a little bit on planetary motion. Geocentric model. So when people believed the Earth was at the center of the solar system, this was a problem because when people were looking at the night sky, they saw this type of movement where the planet would seem to go backwards for a little bit. And that's a problem. You had to be able to explain that. If every single planet was moving around the Earth, then every single planet should simply move in a straight line. So then we had these very complicated ideas that if the Earth is in the center, then Mars must be doing some sort of weird curly-Q model, versus when the sun's in the center, then Earth is going around, and it takes Mars 2 Earth years. And that's why it appears like Mars is moving backwards. So when the Earth is over here, it seems like Mars moves back and then forward again. And here it is explained. So as the Earth passes Mars, because we're moving faster, it looks like Mars goes backwards. So flat Earth theory, this is how they think that our solar system is working. They actually believe we're in this sort of stack model called geocentric or geostacking. So they think that the Earth is the center of our solar system. And so we see planets moving around in just a stacked circle. So Mars would be here, and then Jupiter, and then Saturn, and then Uranus and Neptune, just further and further and further away from us. Couple of problems with this idea. We have retrograde motion, so their model doesn't explain why Mars appears to move backwards. If Mars is just up here making a circle, then it would never appear to move backwards. So their model cannot be true. All right, with the sun at the center, then the movement of the planets in a circle around the sun makes sense. If Earth was in the center, look at all these curly Qs that all these planets would have to do in order to make this come true. And the problem with all these curly Qs is that what force would be involved? Something would have to slow it down and then shoot it back out again. I mean, it's just crazy. All right, and Johannes Kepler is the one who proved 3 laws of planetary motion. The first one is that the planets move in an ellipse. Okay, I don't expect you to know these by heart, but you should know that the planets move in an ellipse. Now, this ellipse is greatly exaggerated. Okay, our ellipse is not too far off from a circle. Okay. But an ellipse is like an egg, like a flattened circle. Also, he says that on the part of the oval where we are closer to the sun, we will move faster. So even though we have a greater part of the area, we're not spending more time here. The months are all equal. So closer to the sun, we get that slingshot effect that you might hear about in TV shows and movies. All right. Mercury, closest to the sun. I want you to remember that it has no moons. It only takes 88 days to orbit, so that's just shy of 3 months. In the morning or during the day, 800 degrees, and at night, negative 279. So really, really not a place that we would be able to live. Venus is the exact same size as Earth, or very close to the exact same size as Earth. No moons for Venus. 225 Earth days, so less than a calendar year. And Venus is upside down, which is incredible. Every planet in the solar system is turning counterclockwise, but Venus is clockwise. And they realized that that actually meant that the axis was upside down. Venus is 867 degrees in the morning or during the day, and then 59 at night. So again, not a place we can live. And you do have to consider that there's something like hydrochloric acid or sulfuric acid in the atmosphere. For the Earth, we have 1 moon, 365.25 days for our year, and during the day, an average of 135, and at night, negative 128. All right, Mars. Now, I'm going to take a second on Mars because we've been acting like, we're just going to jaunt on over to Mars, no problem. And boy, if Earth doesn't work out, then we'll just skip on over there and set up shop. This is not actually a good way of thinking, okay? It's one thing to have a colony on Mars, but for us to act like we're just going to move over there if the Earth gets poisoned. First of all, Mars is less than half the size of the Earth, okay? So if we can't live on the Earth well and correctly, we're going to have a really hard time on Mars. It does have 2 moons, but they're just sort of asteroid-like rocks, not a nice, smooth, rocky moon like we have. The orbit for Mars is about 2 years. So it takes 2 years for Mars to go around the sun per Earth's 1 year. And the average in the daytime is 1 degree Fahrenheit, which is below freezing. Now, in the summer, we have documented, I think it's just a few days in the summer that are between 72 degrees and 100 degrees. But then in the wintertime, at night, we're going to be looking at negative 161. So, I mean, if you forget the fact that Mars does not have an atmosphere that we can breathe, you're also looking at temperatures that on average cannot grow anything that we need to eat. This is why most of the water that's on Mars is frozen, either at the polar ice caps or under the surface. So, Mars isn't like this easy answer. And I think it's misleading for people to act like we can just hop on over to Mars, no problem. Then you have the asteroid belt, and the normal way that we portray the asteroid belt is incorrect. It's not just like this whole ring of rocks. It's actually quite sparse. There are a growing number of scientists who believe that the asteroid belt is a planet that actually broke apart. So it would be interesting to find out what that is. All right, the gas giants. So starting with Jupiter, 79 moons, 11.9, so almost 12 Earth years for Jupiter to go around. This is another one where they act like we're just going to go to Jupiter and set up on one of the moons there. So let's look at the temperatures. The average temperature for the whole year is negative 229 Fahrenheit. And that's going to be the same on most of the moons too. You see frozen methane and other gases. So not going to be very hospitable. Also, the amount of sunlight that Jupiter receives is quite low. So if we're going to grow things, now we need to have lights that we take with us that can produce enough UV and regular light that will be able to make the plants grow. So then without electricity, things become very problematic very quickly. Saturn, 62 confirmed moons, 29 and a half Earth years just to go around the sun. Whew. It's a long time. And average temperature, negative 288 Fahrenheit. So again, the moon's here with Saturn, very, very difficult place for us to live. It's going to be very cold. Uranus, 27 moons, 84 years just to make one trip around the sun. Now, Uranus is interesting because it's on its side. So something came through our solar system and really, messed some stuff up. So it's kind of interesting. People are very interested to find out what happened because the ring is also on its side. So if something really, really sudden, catastrophic happened, then you might expect that the planet is on its side, but that the ring is all kind of shattered. So scientists are interested in finding out what happened there. Negative 357 Fahrenheit. So also, again, icy. Neptune, beautiful Neptune, also has rings. So gorgeous eye here that we have on Neptune. 14 moons. Takes 165 Earth years for Neptune to come around the sun just once. Average temperature of negative 360. And finally, Pluto. When Voyager passed Pluto, we finally got these beautiful images of Pluto. And we'd never gotten such up-close scans of Pluto before. All right, 5 known moons. And yes, I know I'm talking about Pluto, even though it's not technically a planet anymore. 248 years to go around the sun. Average temperature of negative 380, as near as we can tell. So, planet orbits. I've got this here in this diagram for you, so you can see how long it takes. Here's Venus with its clockwise rotation because it's upside down. Every other planet is counterclockwise. Uranus is on its side. Neptune is tipped to a large degree. Pluto also on its side. So interesting what might have happened. Another diagram showing the same differences in axes. And what some scientists are theorizing is that based on math calculations, there's not enough mass in our solar system in order to keep everything balanced. So there's the idea that there's a planet 9 or a planet X. If we keep Pluto, the X is the Roman numeral for 10, so this would actually make the 10th planet. But they're calling it planet 9 since Pluto has been demoted. Supposedly, while our solar system all revolves on the same plane here and goes to the left, this planet goes to the right in the exact opposite direction. And they're thinking it would have to have the mass of, I think it's 10 Earths or something. And I think a revolution of 3,600 years. I've also heard 10,000 years, so we'll see what ends up happening with that. Mathematically, there should be a planet there. All right, beyond our solar system, we have something called the Kuiper Belt that acts as a protective barrier. So if anything's trying to come into our solar system, they would have to deal with this, random rocky field. And there are big objects that are as big as Pluto, some bigger, and so that's another reason people wanted to demote Pluto. The Oort cloud, discovered by Dr. Oort, it's beyond our solar system. We have this huge sphere of rocks. So not only are we protected at the edge of our solar system by the Kuiper Belt, but then also around us is this protective bubble of rocks. So when we talk about, people coming in or, aliens coming from another side of the galaxy, or when we talk about us leaving our solar system and going to somewhere else in our galaxy, there's a lot to deal with and contend with. And then here is what it really looks like, putting the Kuiper Belt together with the Oort cloud, discovered by Dr. Jan Oort. So getting out or in of our solar system would be difficult. Anyway, I hope I reviewed things you already knew, maybe even shown you some interesting things that we do not yet know the answer to. Thank you.